Okay, continuing lesson 13.1. The example, find the value of x for the right triangle shown. So here in this right triangle, I can see I've got an angle of 30 degrees. This is a right angle, so I know that's 90. So I know I have a 30, 60, 90 right triangle. So to determine the length of this missing side, this leg, that's the short leg in the triangle because that's opposite the 30-degree angle. So there's a couple ways to consider this problem. One is I could write a trigonometric equation. I could say the sine of this angle, the sine of 30 degrees, is equals opposite over hypotenuse. Sine 30 equals x over 15. Now right now in this equation there really is only one unknown, x, because I should know that the sine of 30, well, that's just 1/2, because I can refer to my 30, 60, 90 triangle and say in a 30, 60, 90 triangle the ratio is 1 for the short leg, 2 for the hypotenuse, √3 for the longer leg. So the ratio for sine of 30, opposite over hypotenuse, sine of 30 is 1/2. So I can substitute, replace sine 30 with 1/2. Now I can cross multiply and solve for x and I get 7.5. Or, maybe easier, if I know the ratio between the short leg and the hypotenuse in a 30, 60, 90 right triangle, then I would know that this short leg is half the hypotenuse. Hypotenuse is 15, short leg is 7.5. Either way, I arrive at the correct answer, 7.5. So you could pause this presentation and try this problem, find the missing side lengths x and y. So here, I'm trying to find these two side lengths, x, which is the hypotenuse, and y, which is the short leg, the one that's opposite the 30-degree angle. And I know the longer leg is 9, the leg opposite the 60-degree angle. So once again, I could set up a trigonometric equation. I could say, well, to solve for x, I could say the sine of 60 degrees is opposite over hypotenuse. Sine 60 is 9 over x. Sine 60 is 9 over x. Then I could refer to my 30, 60, 90 triangle to determine what the sine of 60 actually is. Well, the sine of 60 degrees, again, I need to know these side lengths, these ratios of sides, know this relationship that the hypotenuse is twice the size of the short leg, the long leg is √3 times the short leg. So if I know those side relationships, then I could determine the sine of 60. Sine of 60 degrees, well, sine is opposite over hypotenuse, so sine of 60 is √3 over 2. Sine 60 is √3 over 2. I can cross multiply now, solve for x, determine that x is 6 √3. So now I know that this hypotenuse, this side length here, is 6 √3. I could determine y in a couple of ways. I could use the Pythagorean theorem, y squared plus 9 squared equals 6 √3 all squared, and solve for y in that manner. Or I could use a trigonometric equation again. I could say, for example, the cosine of 60 degrees, cosine is adjacent over hypotenuse. So for this 60-degree angle, the adjacent side is y. The hypotenuse is x, which we now know is 6 √3. Cosine of 60 is y over 6 √3. Cosine of 60, referring to my 30, 60, 90 triangle, cosine of 60 is adjacent over hypotenuse. Cosine of 60 is 1/2. So substitute cosine for cosine 60, I substitute 1/2. Cross multiply, solve for y, and I get y is 3 √3. The shorter leg is 3 √3.